हेलो स्टूडेंट्स, 2026 मेंस जीएस पेपर 1 में यूपीएससी ने एक दोबारा से ज्योग्राफिकल कॉन्सेप्ट पे सवाल पूछा है जो कि फूजीवारा इफेक्ट के बारे में है। फूजीवारा इफेक्ट जो है, लाइक एवरी ईयर इट इज अ यूनिक ज्योग्राफिकल कॉन्सेप्ट। पिछले कुछ सालों से यूपीएससी कंटिन्यूअसली एक यूनिक ज्योग्राफिकल टर्मिनोलॉजी पे सवाल पूछता है 10 मार्क्स का। एक बार ट्विस्टर्स पूछा था उन्होंने, एक बार उन्होंने ऑरोरास पूछा था, एक बार उन्होंने फ्यॉर्ड्स पूछा था। तो ये सारे इस तरह से सवाल में आते ही हैं। कुछ सालों से यूपीएससी ने ये ट्रेंड बना लिया है कि एक यूनिक ज्योग्राफिकल इफेक्ट को यूपीएससी इन अ 10 मार्क क्वेश्चन पूछ रहा है। तो सबसे पहले हम ये समझते हैं कि ये है क्या। सो फूजीवारा इफेक्ट को एक बार हम ये वीडियो से थोड़ा बेटर समझने का प्रयास करेंगे। सो बेसिकली फूजीवारा इफेक्ट में क्या हो रहा है कि जो दो साइक्लॉन्स घूम रहे हैं, ये जो दो साइक्लॉन्स घूम रहे हैं ये जो दो साइक्लॉन्स घूम रहे हैं, ये कहीं ना कहीं एक एक्सिस को फॉलो करने लगते हैं और उसी एक्सिस के अराउंड अपने आप को घुमा रहे हैं। ये पहला सिनेरियो है। ठीक है, तो बेसिकली आपका हर फूजीवारा इफेक्ट में दो साइक्लोन होंगे जो आपस में 870 माइल्स या फिर लगभग 800 किलोमीटर्स के अराउंड रहेंगे। ये ऐसे घूम रहे हैं, इनकी डिस्टेंस इतनी है। पर एक पॉइंट ऐसा आता है कि ये एक दूसरे की मूवमेंट को इन्फ्लुएंस करने लगते हैं। ठीक है, अब क्या होगा कि इनकी जब नजदीकियां 300 किलोमीटर से ज्यादा बढ़ जाती है, ठीक है, 300 किलोमीटर से ज्यादा बढ़ जाती है, तो ये कहीं ना कहीं आके एक मर्ज करके एक बिगर स्ट्रॉम बना लेते हैं। ठीक है, और एक तीसरा सिनेरियो भी होता है कि ये आपस में इतने दूर घूम रहे हैं और ये एक दूसरे से रिपील होके अलग अलग अपना कोर्स फॉलो करने लगते हैं। ये तीन आउटकम्स हैं जो कि फूजीवारा इफेक्ट की हो सकती है। बट बेसिकली हम क्या देख रहे हैं कि दो साइक्लोन वोर्टिसेस हैं। ये दो साइक्लोन वोर्टिसेस आपस में कुछ इंटरेक्शंस करेंगे। सो बेसिकली फूजीवारा इफेक्ट इज टू इंटरैक्टिंग साइक्लोन्स एट अ वेरी स्मॉल डिस्टेंस। इनके बीच में डिस्टेंस बहुत कम होता है, इस वजह से ये एक दूसरे को इन्फ्लुएंस करने लगते हैं। ठीक है, तो ये है बेसिकली फूजीवारा इफेक्ट। इसमें ये इतने नजदीक आ जाते हैं कि एक दूसरे पर इन्फ्लुएंस करने लगेंगे। अब आप देख सकते होंगे कि ये नॉर्थ अमेरिका का मैप है ना। नॉर्थ अमेरिका और ये गल्फ ऑफ मेक्सिको के नॉर्दर्न पोर्शन में है ये एरिया। तो रिसेंटली क्या हुआ था कि दो साइक्लोन्स थे। हरिकेन बोलते हैं क्योंकि बिकॉज इट इज द यूएस कोस्ट, सो दे हैव अ टर्मिनोलॉजी हरिकेन। सो देयर वर टू हरिकेन्स कॉल्ड हरिकेन इमेल्डा एंड हरिकेन हम्बर्टो। ठीक है, तो यही है इसका रीजन। द रीजन फॉर आस्किंग दिस क्वेश्चन, व्हाट इज फूजीवारा इफेक्ट, explain its impact on the movement and intensity of tropical cyclones. So now you have to keep in mind that because what is part of this question, that is why we will not address the what part in the what part will not be addressed in the introduction. ठीक है, इंट्रोडक्शन में हम व्हाट को एड्रेस नहीं करेंगे बिकॉज इट इज अ पार्ट ऑफ द क्वेश्चन. What will we do in the introduction? We will talk about a current affairs relevance. So last year introduction में we will try to talk about last year. There were two cyclones, Humberto and Imelda. And since it is the US coast, so they were nomenclatured hurricane. So two hurricanes came in close interaction with one another. Came in close interaction with one another, triggering concerns of the Fujiwhara effect. ठीक है, this would be the ideal introduction because it is a part of the current affairs. September last year में ये event हुआ है and UPSC wanted to ask it but it was too late, so then it posted this question this year that Fujiwhara effect किस तरह से हमें influence कर रहा है. So basically this could be the best introduction. If you have a more trivial knowledge or a more nuanced knowledge about Fujiwhara effect, then let us know in the comment section and we will try to incorporate that in our next video, right? So this could be an ideal intro according to the research that we have done. Then after that, we will go for addressing the first part of the question because the first part of the question is what is Fujiwhara effect, right? So what is Fujiwhara effect? We will make it very apparent with our heading. Right? We will talk about Fujiwhara effect. It is best if we can draw a diagram, right? And we will write this as two cyclonic vortices. Close interaction, which is around 800 kilometers. Close to 800 kilometers, if they are coming in this interaction, then this effect is known as Fujiwhara effect. Now, the Fujiwhara effects may be seen in the movement, in the intensity, or the outcome of the cyclones. If you are able to draw this diagram, well and good. You do not need to give a lot of verbal explanation. But if you don't want to show, you want to give a more textual reference, then you can go for writing it all in text that two close cyclonic vortices with almost an 800 kilometer gap come in close interaction with each other and try to influence the movement, intensity, and outcome of the cyclones. Here you could write of both the cyclones. Now that we know what Fujiwhara effect is, the question now asks that it impacts on movement and intensity of tropical cyclones. So movement has been asked and intensity has been asked. This and this has been asked. But we will address this, but we will also talk shortly about the outcome because outcome is the last stage. So we will put it in the conclusion, right? Now, movement. Now, when we are talking about movement, we always try to segregate our answer into segments. When we are talking about movement, we will take cyclone 1 and cyclone 2. Right? Now, when we are talking about movements, we are considering 3 scenarios wherein we will talk about rotating in an axis. We talked about this here when the 2 cyclones started rotating in a common axis. This is the first scenario, right? This is the movement scenario 1, right? Movement will also, the next scenario will be, this rotating in an axis will generally happen if the strength of both cyclones are approximately equal. Second effect will be one wherein cyclone 1 is stronger than cyclone 2, then cyclone 1 will draw cyclone 2 to itself, right? So a attraction effect will be seen. And the third scenario is both are weak. So when both are weak, they will eventually repel each other. And once they are repelling each other, then they will follow separate courses. Eventually, they will lead to following separate courses. So these are the three effects that we can see on movement. One is they start rotating on one axis. If you want, you can draw the axis. And again, it will follow the same course, anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere, like all cyclones, right? Then we will talk about cyclone 1 and cyclone 2, wherein one is stronger than the other. Then there will be an attraction force wherein one cyclone will be drawn to the other. And the third scenario, we can talk about repelling each other. So for movement, you can either draw this table or you can give it as separate side heading: movement, effects on movement, rotating on an axis, merging, and repelling. So these are the three side headings you can use. And the third is repelling. The next part of the question, so we've addressed the first part, which is movement. Then we will go to the next part of the question, which is intensity. When we talk about intensity, three things can happen. Either they might magnify, or they might accelerate, or they might retard, right? So either वो ज्यादा तेजी से जाने लगेगा, या फिर वो कम तेजी से जाने लगेगा, या फिर वो दोनों आपस में मर्ज होके एक हायर मैग्नीट्यूड का साइक्लोन क्रिएट कर देंगे. तो दीज आर द इफेक्ट्स. अब देखिए क्या होता है. अगर ये 300 किलोमीटर की दूरी पे आ जाते हैं, इफ दे कम क्लोज टू 300 किलोमीटर, then there is a high chance that they will merge to form a higher magnitude cyclone or a higher intensity cyclone. If they accelerate, that is generally happening when they are at a distance of 600 kilometers, then they will show a speeded tendency, drawing fuel from each other. They might take energy from each other and accelerate in their path. Again, in all these cases, the issue, or why is it a concern, is because it becomes very unpredictable. Now, as you are aware, there are meteorological scientists all over the world who try to predict the course of cyclones, who try to predict for disaster management. They try to make cyclones a bit more predictable and a bit more uh, manageable for mitigation, for disaster mitigation. So that is the issue with this Fujiwhara effect, right? And then there will be retardation. That is when this happens in the case of weaker cyclones, right? So in one, there is domination. In one, there is submission, because the weaker cyclone will start to follow the stronger cyclone. And then there is retardation when there are both weak cyclones, right? And as I said, The conclusion could include the unpredictable nature of cyclones when a Fujiwhara effect comes into play, and it becomes difficult for disaster management. Early warning systems and information dissemination. Right? With this, we can address the Fujiwara effect. And in case you can get us a better intro, I would like to know it in the comment section. Thank you for watching our video.